So a graph structure on C. And I'm gonna do that for this time here. Not sure how hard it's gonna be, so I don't know how long it's gonna take. I think I'm going to look at the other functions that he did on the other project, and I'm gonna try to do things in the same way that he does, because it's probably gonna be easier. The biggest part that I don't know is like how should I make this stuff and test it, because in Python or JavaScript it's very easy to like write the stuff that I want to write and then test to see if it's working. But on C I'm gonna have to compile. So the thing that I thought about is just creating another makefile here, and then I think this is the most annoying part in the beginning, is like figuring out how to what is the best way to structure things so I can test, build the stuff, then run and see if it's working, and also console log stuff to see the outputs, which I'm not used at all. I think that with Rust I did that, but it's also different because I think it's probably easier in Rust since I used cargo to run, and then it does everything. Like it creates the compilation and also creates the organization of the files. But it was also a little bit annoying, I remember, because the way you separate the files is different. So also I think I'm gonna open the other project and I'm going to get the data structure for the nodes and edges, and then I'm just gonna copy the data structure here. So what I'm thinking about doing is just creating a struct for the node and a struct for the edge, and then another one for the graph that is gonna contain the list of nodes and edges. And then I'm gonna have to think, but I'm probably gonna use a vector instead of using an array, because I've seen that it's easier to work with vectors and arrays. I think you have to to specify the size, so it's more complicated, but it's more complicated, but it's faster. But I think using arrays is probably the best. I should remember where I put the graphs. Oh, here? No. Functions. Let's see. Let's not copy this on the other one. This is another thing that I'm not used to, which is to specify the type of the thing, but it's not that big of a deal. I think this one, but it still is gonna take some time, I think, to get used to. I think it's char for strings. The thing is, like, he uses char for strings, but I think that char is for a character, but since he uses for strings, I think it's fine. But I don't understand really well the difference. I don't understand if there is a a type that you can specify in C that is for strings. You know, it's probably just characters. Yeah, char. And the other thing is when to use the pointers as well. So I have to think about that. Const char. I think I'm gonna make everything in the same way as it is on the other one. Like I'm gonna save everything as a string and then I pass, instead of saving as the hex number. Maybe it floats better. Maybe I think I'm gonna do int because it doesn't matter that much. The thing that I'm thinking about using the radius for is just for the frequency or for other stuff like that. But I think having int is fine. But maybe in the future it's gonna be better. Like the thing is, it's kind of difficult to think about situations where you would make a big difference to have floats or instead of integers for determining the size of the radius. So I think I'm gonna leave like with integers and then I'll think about this later. If I don't specify it, it's probably gonna be no. So, but I'm not really sure if there's if you have to say, because in TypeScript you can use the question mark operator if it's an optional thing. In JavaScript I'm not really sure if it works that way. Because obviously not all nodes are gonna have all these properties. Now, what I'm gonna do in the beginning is just try to I'm gonna initialize the graph nodes. So I have to spend a bunch of time thinking about what is gonna be the best way to like implement everything. That's the hardest part. But what I'm thinking now is just to initialize I should probably initialize here instead of this one. Because the rest of the stuff doesn't matter. Everything's gonna happen inside of this function. So I should probably define or include the other thing is that the way he did this is for 32-bit Windows. And my system is 64. So I tried to replace the commands here with 64, but it doesn't work for some reason. I don't remember really well, but I got an error. I think it's because of the commands, yeah. So the way that he designed everything is like first you create lexers and then parsers. Then the other stuff I didn't have access to because it's part of the other courses. But as far as I understand now, the way that it works is after you create the parser and the abstract syntax tree, you're gonna use that to build assembly code. And that's the generation part, I think, generator part. And then with the assembly code, you compile down to binary. And then the way that the assembly instructions are gonna be made is gonna depend on which system you're using. And also I realized this now. And like, I don't know why. Actually, I know why I didn't realize it before. But every time that you're gonna download something, there's always the option to download in Windows, Linux, or Apple, or Mac. And as I was thinking about this stuff, I didn't realize this, but yeah, it's pretty normal to have this separation. And the reason why you have the separation is because depending on which type of operational system it is, there's going to be a different set of instructions, which is the way that the assembly is going to become machine code, because that transition is always arbitrary. So different operational systems have different standards for which assembly instruction is going to mean something. So there's different assembly languages, and that's the reason why I think most of the places you have to download different things for different operational systems. And the name of the way that the assembly is going to become machine code is instruction set architecture, I think. ISA. So depending on which one it is, you have to create a different code generator, because it's going to obviously create different assembly instructions depending on which type of architecture you're building the compiler to. And there is a way to build it in a cross operational system way. I'm not really sure if that's the way that you say it, but there's a way to develop so that it works on all operational systems, but then obviously it's a lot more complicated because you have to put a bunch of options. So one error that I was getting there, it was because of the Linux file that he was defining here, which defines the maximum size of the path, the string that is going to determine the path. So the way that it works is that you have the string of the path, and there's a bunch of algorithms that are going to take that path, and it's going to break down into points, and it pretty much finds the location of where the data is for the file on the disk. And the data contains the metadata of the file, which is going to be the specifications. And each file system has a different way that they structure the data on the disk. And the FAT16, which is the one that he uses on the other cores, which is one that comes from the Windows, they divide everything in clusters, which is just pretty much a way to say like a set of amount of space for each file. I don't remember if it is for each file, but it separates everything into clusters, and then each cluster is going to contain the data for files. And then the path resolver is going to get the path and see where the data is for the file. And you have this max path variable that comes from this one. And because he was using Linux on the cores, this was getting an error, so I had to ask ChatGPT how to do this, and I got like some variation of this response, and then I was able to figure out. But for Windows, you have the name of the max path is different because the variable is different, and that's just like an example of the differences in how the architecture of the system is going to determine these kinds of things, which is the way that the CPU is going to handle the memory management. So based on the way that he did things, he did for the 32-bit system, and also the 30 is 32 bits because in the RAM, I think, I'm not 100% sure if it's on the RAM, but the size of the word, which is going to be a row in the RAM, is going to be determined by this number, which in 32 bits is 32 bits, and 64 bits is 64 bits. So, and that changes everything in the way that you're going to encode the assembly instructions, because you have to specify like how you're going to use the registers and move the data around. But I'm not really concerned with that part, because I think that for the stuff that I'm trying to do, it doesn't matter that much. What matters more is being able to deconstruct the code and build a visualization out of it. So I think that the lexer and parser are the most important parts, but it will be nice to study that part as well. And the other thing that I realized as I was doing this, and is also something that I kind of take for granted, which is I forgot that the main implementation of Python is in C. And then I realized that because the way that I was thinking about is like, I'm going to use this thing here to change this code so I can build my own stuff, so I can parse Python later on. But then I remember that Python is implemented in C, like the main implementation is in C. So what I can do is just use this to parse the C code, which is the Python interpreter. And I also found another JavaScript interpreter that is in C. And I can use what I built here to parse those things, and then use the graph that I get as a result as an experiment to know like how to improve the thing. And then pretty much I'm gonna like bootstrap the process. If I'm able to do that, then I can understand how the interpreter for both of the other languages work, and then I can use those interpreters to modify them and to create graphs out of them for Python and JavaScript. And Python, it says that 40% of the repository is on Python, but those is just for the standard library. The main core implementation of the Python system is written in C. So hopefully I can do that. But here, I'm not really sure. I think, yeah, I specify like this. And I think on the Mac file, the only thing I'm gonna have to do is to change the way that the include is here. I think this include specifies for the linker where to look for the function declarations. So the linker is the thing that is gonna connect the declaration of the function with the definition, which is the way that the function actually works. I think I'm gonna copy this stuff and I'm gonna just try to keep like the same thing and just change whatever is necessary to run. And I'm going to build the stuff here and see if I can use the make command inside of this directory to create the executable there. But the biggest problem is how to pass. Based on the way that he does things, is probably the way to do it is probably just to compile and run each time, and uses GDB as well, which is a debugger that allows you to put the breakpoints and then like step through the code. But yeah, if I'm gonna do it like this, I have to think if I'm gonna compile and run each time. I'm probably gonna research now how to make it so that I'm only compile. The problem is that I have to compile everything. That's the issue. Because what I want to do, obviously, is just, and this is the habit that I have from other languages. What I'm thinking about doing now is just to, I'm gonna create the graph first, the node and edge structures, and then the graph structure. And then once I have that, I import that on this file here. And then I declared in the beginning of the function. And then at the breakpoints that I want to extract the information, I'm probably gonna have to modify the function so I can pass the graph as well. That's probably what I'm gonna do, because it makes more sense to declare here and pass here. So I'm also gonna have to think about, I'm probably gonna use this ampersand here operator, which is probably passing only the memory, the reference to the memory, not the thing itself. But I'm gonna use ChatGPT to clarify this as well. But what I'm thinking about doing is just, I want to print the things to see what exactly I'm getting on the tokens. So I'm thinking about getting the lexers, the token lexers, which is inside of this function. Yeah, this token here. Probably from here, actually. Yeah, I think from here is better. So I put inside of here, each time after it creates the token, I use a vector function probably. One of the functions from the vector library he provided. And I append the token to the node list. Or I have to create a function on the other file that is going to receive the token. And it's going to translate the information of the token into a node. And then I have to think about how I'm going to, like what logic I want to do to build the edges. But it might be better to just append the tokens like after. So append it here, because I can separate the tokens based on type. And I'm gonna have to remember like how this is done. I'm probably gonna go over the course several more times still, because it can be quite confusing. So yeah, but I think I can create the logic for the connection later based on the token type. So, because it's probably going to be easier to just append. This kind of decisions is going to depend based on the type of graph. And that's the part that is kind of difficult to think about, because I'm not really sure. And the problem is like what I've been struggling to think about since the beginning, because what I want to do is not build a compiler. I want to build something that is going to allow me to visualize how the language works, or how a software program works. So the question is what is the best way to capture the connections in the way that is going to be meaningful. And the problem is that because of the way that this is structured, it makes a lot of sense now that I think about it, and that I've seen the way that he does it, because breaking everything into tokens makes it easier to build like meaning out of the tokens. So for example, for the expressions, it makes a lot more sense to build the expressions after you know what each thing is. So if you have an operator, or if you have an expression, or if you have a keyword or something, or a number. So if you know what each thing is, it makes a lot easier to build this stuff, to put this stuff together in a way that is gonna create a higher meaning. And that's where the parser parts comes in. So, but the problem with that is that, like, I have to think on a higher level way to know, to think about like what exactly do I want to extract from the code, and then based on that I have to think about at which parts I'm going to extract the information to create the graph structure. So, and this is what's going to change the connections that I'm going to make and the attributes of the visualization. So yeah, and obviously I'm not really sure if that's going to be useful or not, because I remember doing this with graphs in the past, and you can feel like it should be a lot more useful than it is, because like even though it looks good, it doesn't have a lot of utility. But I think that it makes sense that there must be a way that using a graph is going to become a lot easier to understand what's going on, because the way that I think is that what I'm doing is just increasing the dimensions of stuff that I can extract from the code. So, for example, I can use the levels, which goes into the hierarchical graph layout. I can use the mass, I can use the size, and I can use the color. And then obviously the edges. And all of this stuff can be converted into meaningful information. So for example, if you look at the graph and the size of the node means something, then it might be a lot easier to understand what's going on just by looking at the size of the nodes, because it's a lot more obvious. And if you just look at the code, it's going to be a lot more abstract. But the question and the challenge is, like, what exactly... obviously, I don't know if that's the case or not. And if it is the case, then what exactly how do I exactly extract the information in a way that is going to allow me to, like, build the graph that is going to make sense? And it's very hard to think about. And this question is obviously directly related to what I'm trying to do now, because I have to think about what places should I put should I convert the tokens and the parsing things into the graph. But I'm gonna try to not get overwhelmed as much as possible and just focus on the stuff like one step at a time. Otherwise, I'm gonna go into paralysis by analysis. That's the thing though, is that actually I think I'm not gonna create this part I probably can delete here, because I don't want to create maybe it's GCC graph. I don't want to create the executable, I just want to compile everything. I guess this is the question, is how should I do this? Because I think I have to execute from the main file, because I'm gonna see, or maybe I should think about this, or how to ask ChatGPT, like what is the best way. So what I'm contemplating now is whether or not I should try to execute the graph C here, because obviously I want to see if the stuff that I do here makes sense or not as I build. But then at the same time, I don't want to create an executable just for that. But maybe it makes more sense to create the executable and then I just like execute each time until I think I have the functions that make sense and the structures that make sense. And then once I get to the point, then yeah, because I can use the other make file to execute everything. So it probably makes more sense actually to create the outputs there. And the thing is that there's not gonna be a main function. So this is something that I don't understand. So I'm gonna have to ask ChatGPT. Let me think about it. Because the other one, when you compile and create the executable, it's not calling the main function anywhere. So I assume that in C, whenever you want the program to run, you have the main function has to be main, and then it's gonna run. So maybe I should, instead of naming graph, actually I can make other functions and then obviously just name one function named main instead of graph, just to test, but that doesn't make a lot of sense in the other context, so I'm gonna have to remove anyway. It's kind of hard to think about a good way to ask this question. What I want to ask is, how is it possible that how is it possible that the executable of this runs the function without calling the function? I guess the easiest way is just to do it and then test. This is something else that I'm trying to become better at, but it's one of those things that it is like a never-ending journey, I think. Because the tendency that I have is always to think about, like, spend more time thinking about instead of executing. And it comes because, like, you don't want to fail and then have to deal with the process of failing. I think that's just natural human nature, because you're always trying to rationalize your behavior so you save energy and minimize risk. So if you run this stuff, then you have to face the unknown, which can have infinite complexity, and then you don't know how much time it's gonna take for you to figure out. But if you don't solve it, then it becomes easier because it can be on your comfort zone. So, but at the same time, it's like nuance because it depends on the circumstance. So. Because for example, like, it's like a risk-reward ratio thing, I think. If you are contemplating whether or not you jump out of a building, then obviously, like with a parachute, for example, then obviously you should. It's much better to be in paralysis by analysis in that case because the risk is a lot higher. And the problem is that the human beings they're not very good at assessing risk because the limbic system is always lagging behind. So, like, your subconscious system is not very good at understanding like what is happening right now. So the default for humans is always to go into a scarcity mindset and to avoid risk as much as possible, because that's the way that nature programmed us So, and that's something like I realized in poker as well. Like, and it's probably, it follows the Pareto distribution. I think 80% of the people are more risk averse, so they fold more often and they don't bet, and that allows people to exploit. So, and it's usually like this circle thing where in the beginning, like the people that don't know how to play are gonna be very aggressive because they don't understand what they're doing. And then as you become a lot better, then you become overly passive and like the neat that they say, because then like you are aware of how your actions are gonna have bad consequences. So, and then the balanced perspective, you come back for full circle, and then it changes the main thing that changes is the way the place you're coming from. And I think that's true for everything. So I think I'm gonna try to just leave it like this, because obviously I want to, but maybe I don't need this. I was gonna say that I'm probably gonna use the compiler H here. Yeah, I'm probably gonna use it actually, but maybe not if I put inside of the function, because the graph C. So let me think about it. So I'm gonna have a function that creates the graph. I'm gonna see how. Should I return a number or not? I should return the graph, obviously. It's probably gonna be a struct, a graph or something like that. Great graph. So I have to declare it here. So let me build the struct first. So I was thinking about, I'm probably gonna use compiler, define compiler H here, and if I do that, then I have to specify through the makefile to go back one directory up, so I have access to the compiler H thing. But now that I think about it, I might not even need that, because I can create the functions and then I accept on the functions the parameters, so this file doesn't necessarily need to have access to the thing, because I'm not declaring the variables here. But maybe because of the way the C works, I do have to put there. But I'm gonna try without putting that first. So I'm gonna try like this first, and I'm just gonna try to run and see what happens, and then if it doesn't work, then I think about it. Do I need? Oh, I think I need to compile the other ones. I just, oh no, it's correct. Oh, here. I don't understand really well how it works with the object files still. Like this commands here. The one thing that I don't understand is it seems like it runs first. Like it's calling the graph.c file, and then it's calling the header files, and then it's calling all the other objects here. But the question is, how does it call the object files before it builds them? That's why it doesn't make sense to me. But I think what it's probably happening, but I don't understand really well, is as it is running this command, then it runs the other ones maybe. And then the other ones are the ones that build the files. So I'm gonna do this one first, then I think about the rest. I just realized that's probably better to use this syntax instead, since on the other ones he's using this syntax. Yeah, so now I'm gonna focus on building this stuff. Yeah, so I think for the nodes pretty much it. Then I do the edge. Then one for the graph. It's gonna have ID and source. The question is whether or not I should use this. I'm gonna ask here. I'll ask what is the difference between the point. I think the star operator, or however you say that, is for assigning the pointer, and the ampersand is for getting the reference. So when you assign the pointer, you're creating like the name says, a pointer to the thing in memory. And when you're using the reference, you're getting the address of the thing, which is not the thing itself, it's just the address that contains the data, I think. But I'm not really sure. So it's probably, I'm gonna do like this just because it is like this on this file. So it's probably correct. Yeah, but this one it doesn't have. But I think it's better to use this one. This one here is the one that he uses to assign the value of the token, which I think sometimes is related to a buffer. That's all, let me think. And that's pretty much it, I think. ID label, color, radius, level, mass. I guess I'll think about this later if I forget something. So I'm probably gonna do it. Oh, here. So ID, source, target, label. Color. And here I'm not gonna need to do the node map thing. I'm gonna leave everything else obviously to the front end. Maybe not obviously, maybe it's better to do it at some point. But yeah, I think it doesn't make sense to do it in the backend, even though it would be faster. Or maybe it does make sense actually. But it's gonna take a lot more work, so I'm gonna have to think about that later. I think it makes more sense for me to focus now on just building the graph in the backend, and then I pass the graph through the front end because I already have all the... The thing is, I need to create the other data structures to create a bunch of other things like events and animations, and also the... like in some other parts that I forgot, but I know that I need the node map for some parts. But I also, at the same time, when I was studying this before, I remember that the guy says, like one of the guys that's created a library that I was using before, I remember seeing one video he did, and he says that it makes a lot more sense to build this stuff on the server and pass to the front end, and I think that makes sense. But the problem that's with that way of thinking is that I'm using 3JS, so I think it doesn't make a lot of sense. Like, I can't build the graph in fully on the back end, because 3JS is on the front end and is the canvas, and 3JS is the stuff that is gonna build the structure that is gonna actually be connected with the buffers. So to a certain extent I have to build it on 3JS, but at the same time maybe it makes a lot of sense to like rethink the way that I did things and try to build everything here. Like I build all the structures here, and then I put all of them in JSON, and then I send the JSON. And maybe it's worth to think about that, maybe not now. The problem with that is that it's gonna change everything, that's the issue. And this is why it's so difficult to think about this stuff. Because I don't know how these things are gonna evolve. But it's probably better. I'm gonna focus now on just building this stuff, and then I'll deal with this later. I'll change later. I'm gonna have to change it anyway once it's time to scale for doing a bunch more stuff. Yeah, I think in the first part it's probably better to just spend time trying to iterate on the graph itself and try to figure out what ways I can structure the information so that is more effective to learn. And then once I have that figured out, and I have for all 3 languages, which is going to take a lot of time probably because it's very complex. But if I'm able to do that, then at that point when it's time to like scale for all of the projects on GitHub, then I think about like what is the best way to go about doing that. Because there's the trade-offs. I think in C is going to be harder to develop, but then it's better because it's faster. And then there's going to be the question of whether or not it's better to try to put as much stuff on C as possible. Because what's going to matter the most, I think, is the way that I structure the information. I think the visualization is a very big part, but the structure of the information is probably the most important. And that's going to happen on the back end. So yeah, now the graph is the one that I'm not really sure about how I'm going to do it, because I'm going to need the vector. I think the vector makes more sense, so I initialize 2 different vectors, because I'm not really sure, maybe I should ask ChatGPT, but the array is probably necessary to specify a size for the array, and the vector you can just initialize and then is dynamic allocated, the memory. So the way that he does it is he uses kloc or malloc a lot, which just creates the thing on the memory. So I'm gonna find the function here where he does that, and I'm gonna copy. So first you initialize with the... oh, this one I think he does it. this one. You create the thing in memory, and then you create a vector out of that thing. Yeah, that's what I'm gonna do. So let me think. I'm just gonna copy this stuff, then I'll change. It's interesting that he uses the... This is very challenging as well. Like, what is the best time to use this stuff? Because here he uses the reference, probably because this is void and the other ones are not. So the other ones are better to create a pointer to the function instead of defining, but when it's void, it's not. Yeah, but here he doesn't do it, and it's kind of hard to know what is the point. So I'm gonna ask ChatGPT, but I'm gonna think, contemplating whether or not to do a C course. I'm probably gonna do it. I already found one, so I'm probably gonna do that. But the problem with the courses is that, which it is part of the reason why I'm trying to build this stuff, because like it's very hard to find people that focus on the thing that actually matters in my way of looking at it. Because most people are... Also is because it's probably a lot harder to do it like that. So it's just the nature of the system itself, not the specific individuals. Just that the system incentivizes you to focus on the stuff that doesn't matter that much because of the nature of the search, which is the paradox of search, which is the structure of the collective consciousness. Because the way that it works is kind of like a sphere. So the things that matters the most are the things that you are most uncertain about, because otherwise it would be normal, and that's how gravity works. So because of that, whatever is normal is not very useful because people already know, but what's not normal has a lot of risk because it can be wrong. So there's a lot of variance, and because of that there's a lot of resistance, and because most people are designed to most people, not everyone, is designed to try to like maximize the energy efficiency and minimize risk. So everyone's trying to constantly save more energy and take less risk, and because of that it's going to follow a Pareto distribution, and it's going to create the structure of the funnel of information that's some 20% of the people are going to explore the unknown, and then 80% are going to stay on the known, and then the 80% are going to have the tendency to resist the new information, because otherwise you lose your mind, because you have to protect your identity. So this creates the paradox of search, because then 80% of the people are always going to be looking for things that are superficial, which makes it less... It creates less of an incentive to expand the current knowledge that people have, because you're not going to gain too much and it's harder. So everyone's incentivized to always generate stuff that people already know, or that are more comfortable about it, and that creates the situation where the search engines are going to show the results that are superficial. And also because of the nature of specialization, because everyone's trying to save time and there's an infinite amount of problems. So what happens under the lens of the market economy is that everyone specializes in their own thing, and then through coordination you achieve the computation of the collective consciousness, which is based on the pattern of reproduction that creates technology. And because of that, it's like a funnel based on gravity, that everyone's going to specialize on their own thing. That's the reason why search expands on a tree graph, I think, or on a tree format. Because the deeper you go into a subject, the less people are going to be interested in that, which is going to create less of an incentive, and then it creates a vicious cycle. And then part of the reason why, like, the way that people solve this is by telling other people to focus on niches, because then you have less competition. So, and that's the nature of the markets. So people specialize, and that's the reason why it's very effective, because you don't have to know all the variables beforehand. You can compute in real time what the technology is going to be, because people want money, so they're going to specialize on niches so they don't have to compete with the bigger brands. But it's very inefficient, because is not most people are not going to produce the thing. And this goes back to this stuff here, because what matters the most is this distinction, I think, of how do you find what is fundamental. But I forgot the main thing that I was going to talk about. I was saying something. I forgot. I was going to say something about this. But it's the reason why I went to this whole train of thoughts. Oh yeah, the courses. So the reason why I think that the course is not going to be very useful is because probably he's gonna say is stuff about the, and this is the main fundamental challenge with programming, is that most people are gonna say like how the thing works and not when you should do each thing, because when you should do each thing is hard because it's gonna depend on the context, and the context has infinite complexity, so it depends on the situation, and that's gonna be the whole path of getting skill into something is gonna be feeding your neural network to understand the complexity of the geometrical structure of the thing that you're trying to understand. And that's going to depend on context, it's going to deviate, it's going to converge to infinity. So it's much harder, and that's the question of when. So it's not so much about like how to solve the problem, it's about how do you find the optimal way to solve the problem. And the optimal way to solve the problem is going to be a funnel of information that's related to the density of computation of a reference frame that creates a gravitational force, to the perspective of an awareness that parses infinity into space-time. I think I'm confusing. I shouldn't be doing this here. Yeah, this is inside of the function. So I need to think about... Yeah, I'm gonna find how he declares something that uses a vector. Gonna declare the graph first. So it's probably gonna be, no, it's gonna be a vector of objects for both of them. So a vector of structs. One of them is gonna be a vector of nodes. So I have to see how to do that. Vector of graph nodes. Operator precedence, he does that. But I'm not really sure if the way that he specifies there. I'm gonna use ChatGPT. But he specifies, maybe it's an array in the way that he specifies it. Or I can just ask directly how to initialize a vector of nodes, but maybe ChatGPT is not gonna give me a good response because it's based, like the vector here's are gonna be based on the, oh, I just realized this now. So I'm gonna have to change the makefile because I'm gonna use the vectors thing, which is on the helpers here. So in order to have access to that, I think I have to do this. But I'm not really sure if this is gonna work or not, so yeah, we'll see. Yeah, here. So maybe instead of... Yeah, but here, he's only assigning the thing. Like this is a number, which is going to be 14. And this is amounts of the... So what he does is just create a struct. It's create a list of structs, and then each struct has a order of precedence of operators. And then he creates a nested loop to find the order, and then he shifts the nodes based on the order. Also, I highly recommend, obviously, watching the course. Like, he explains a lot better than I do. And the reason why it's hard, like, I think this is important to say as well, so, yeah. But, like, not saying that individual people teaching stuff because a lot of people are not gonna understand what I'm saying. So, but like, it's not the problem, and I try to think like this as much as possible, where it's never the problem of the individual, and it's kind of stupid to focus on the individual, and it's one of the reasons why I think elections are pretty dumb, because it doesn't matter. Like, if the system depends on an individual person to make the correct decision, then it's a shitty system, because the variance is going to be very high, so it doesn't make sense. So if you're thinking under the lens of the scientific paradigm, which is through experimentation, what's going to matter is the density of computation in relation to a reference frame. The density of computation is going to be the connection of past and future in relationship to a reference frame. So that's how you're going to create a function of information of what you consider to be right or wrong, which is your epistemology, I think. So it never makes sense to say that, like, to focus on the individual, and the only reason why people do that is because your subconscious system is always trying to make you minimize energy and minimize risk. So instead of thinking as a person or as the complexity of the system as a whole, what you're gonna do is just reduce reality into a concept, because that makes it easier for you to understand. And that is effective, and that's the reason why most people think like that, and it's gonna follow the Pareto distribution again, because most people are not gonna contemplate about life because they don't have the brain processing power to do that. But the problem with that is that then you become biased, and then it creates a lot of destruction, because the consequences of that is that you're not going to focus on the system as a whole, and you're just going to simplify everything. And then the conclusions that you get to are always not going to be in alignment with the nature of the whole, which means you're going to be lacking balance with the whole. And eventually, because that's the nature of space-time, it's going to break you, because you're not in alignment with space-time. So it's same thing here, that it doesn't matter that it's not a problem that the people don't do courses that are effective. The problem is that the system is structured in such a way that it's going to incentivize most of the people to do courses like that, and then it's going to follow like a probability, because everything is going to work on probabilities, I think. So it's like the amounts. There's the relationship between the probabilities of genetic distributions. They're not going to create certain types of behavior, and it's going to create tribalistic thinking, and it's going to reflect on the way that culture evolves. And that's always going to be based on a percentage, because it's the same thing as saying that like we should saying that killing Hitler killed Nazism, which is obviously not the case, because Nazism is a probability in the human nature. So you have to think about the system in a way that takes into the consideration the probabilities of certain personality types, and how that's going to translate into the distribution of power and the way that the people are going to behave. So I think this is the reason why it's very hard to solve that. It's probably, it is the same problem with colleges and everything else, because it's very hard to define level of skill, and I think it's exactly because of the same reason why it's hard to search things, because you don't know what's true until you compute that thing for a long time, so you have a higher degree of probability that's right. And it's the same thing with code. Like, the more complex something becomes, the more it goes against the paradigm of scientific thinking, because you need more experimentation to know if it is correct. But if you don't have the probability on your side, then you're not gonna know. So if you have an event that only happens once in a lifetime of the universe, it's impossible to predict if it's gonna happen or not, and you can't say anything meaningful around that. That's why it's always a funnel of information, I think. And it's pretty much the same thing here, I think. The only way to know like what is the best time to do each thing and to break things down is to create a funnel of information that's probably going to be a graph network that captures a multifractal pattern of the gravitational force of the information that creates the code structure. So I think I'm gonna ask ChatGPT how to declare, because it's not necessarily this example that I wanna follow, the one that I found there. Let's see how. I think that one, it just initializes the thing, but yeah, this one. But doing this there, I think it doesn't make a lot of sense. Or maybe it does. No, it's not defined, it's included. Yeah. Not sure why sometimes it doesn't show anything there. I should search for a vector instead. Also, he just assigns like this, but this is a struct. Also, in the vector you have the struct. Interesting. So he just initializes based on the name. So I guess that you don't need to know what the thing is before. Maybe he declares the thing first. I think he probably declares this on the beginning of the file, or maybe not. So probably I don't need to specify what it is, just write the name. Maybe he does it on the H files somewhere. No, just yeah. It looks like this is all from the standard library in C, so he doesn't define anywhere this name here. I'm trying to understand. I probably don't need to define whether or not I need to define this, so I'm probably gonna initialize in the same way that he does there, and then just change the name here. So what can I say here? The thing is, if I name nodes, I'm not really sure if it's gonna conflict with the nodes from the tree, the parsing tree. But maybe I'm just gonna put nodes here, and I'm gonna search on the other one to see. The thing is, I'm gonna have to go over the functions to see if it's used anywhere. Also, no. So I have to see if nodes is used anywhere. He probably just uses node instead, so I think nodes is fine. Edges obviously doesn't exist. So probably that's the only thing I have to do. Probably I made some mistake. Here I didn't put this. Yeah, so it's gonna be just a vector of node structs and edge structs. And then later so first I'm gonna do that, then I'm gonna see where I can put the graph, where I can put functions. Oh, actually, I didn't realize, but no, the functions are separate. So I'm gonna declare the functions here, and then the functions are gonna use the graph, this graph here. So I'm gonna create the functions to initialize the graph and then to append nodes and edges to the graph. But maybe I don't need to append, but I can just use the functions from the vector itself, the vector library. This is probably what I'm gonna do. And then I figure, oh, but actually I need a function. Yeah, I'm gonna do it here actually, because I need a function in between to decide how I'm going to convert whatever information I get from the lexer or parser into a node, into the node struct. And then from the node struct, I append to the graph. Then once I have the graph, then I have to figure out how to save it into a JSON. Then once I figure that out, then I'm gonna figure out another function that goes over the entire directory, so I can parse like a whole project. But I think it might be better to focus on building the graph first. So first I have to build the JSON, and then I have to test on the front end to see how it's gonna look. And then I have to ask myself questions of which information I'm gonna get, which I already have an idea, but the hardest part is figuring out, because the information is not gonna be exactly the way that I think, because the way that I was thinking in the beginning, and I kind of already knew like it wasn't gonna be the same, but obviously I just was thinking based, so I have like a understanding of like which direction I wanted to go. But I was thinking more in terms like, for example, I'm gonna grab the name of the variable, and then I wanna follow the execution of the variable, like the way that the variable changes across the whole program. So that's one of the main things I wanna do, I think, because I think that's gonna be very useful. But the problem is that in the lexer, I think that the variable is gonna become a keyword on the token. And then on the parser, that keyword might be used to construct other things. And then the question is like how I'm gonna capture the information based on that, because it's gonna have to be interconnected with the code for the compiler, and that's the problem. That's the hard part, because, for example, keywords are gonna become arguments in certain functions, so I'm gonna have to put logics at the point that he creates the arguments of a function, that he uses some buffer, and he is building the abstract syntax tree. I'm gonna have to put some logic that figures out whether or not a variable that I'm tracking is the same, and that's gonna make things a lot very complicated. So I have to think about like, what is the best way to structure things so that, which probably there is a pattern, like the best way that I can structure things so I can extract the information. And obviously it's easier if I put the functions here and then I just put like at specific places. Maybe that's the easiest way, but it is the easiest way, but I think it's probably not gonna work for all the cases. It's probably gonna be a range, because everything in life works like this, which is gonna be a symmetry, so there is a polarity, and then the best strategy is gonna be on the middle, because it's the convergence of the relative polarity, which I believe is paradox. So the way that I believe that space-time works is that at the boundaries of perception, you have a multifractal pattern, which is the illusion of distinction between things, because everything is one thing at the end of the day, which is God or universe or whatever you want to call it. And space-time is the parsing of infinite potential into this fixed space. So infinite potential becomes fixed space through time, through a multifractal pattern, which is the frequency of computation of an awareness that creates the illusion of convergence of relativistic polarities. So, and that's the principle of gender, or the symmetry of the electromagnetic field, where you have a gradient of distribution of polarities. So you have masculine and feminine. Between them, you have a symmetry, and then these symmetries are symmetrical in relationship to other symmetries. And the absolute structure of the relationship between all these symmetries is going to create a multifractal geometry, which is the patterns in space-time, which is geometry itself. So everything at some level is going to converge to other levels or perceptions of other symmetries, which is an illusion, I think, but it is the way that time works. So geometry changes in a certain way based on the computational frequency of a network that creates the illusion of the convergence of higher order levels of symmetry. So if, for example, you have left and right in politics, inside of the left and right spectrum, you're going to have a bunch of discussions that are also symmetrical, because they define themselves into left and right. But at the bottom of reality is infinity, so you don't have this distinction. And the nature of distinction itself is the convergence towards these relativistic symmetries that creates a multifractal geometry. And I think that any problem is going to be like that. So here, there's going to be one end of the spectrum and the other end of the spectrum, and the best approach is going to be the convergence of the two, which is going to depend on the circumstance, which is the computational frequency of the network. So here probably one end of the spectrum is doing everything outside of the compiler and just getting the information. So for example, I just append the tokens and parsers or whatever, or nodes, whatever structure the compiler creates. I just append here and I completely isolate the functions for the graph with the functions from the compiler. And it's very easy. And the other approach would be I do everything inside of the compiler. I think those are the two sides of the spectrum. And I think depending on the information that I want to extract, it's probably going to be a convergence towards the not the middle, but the relativistic complexity that is going to depend on the nuance of the situation that I want to parse. So it's going to be a distribution over the two. So it's probably going to be better to create some functions here and then to also create some stuff inside of the compilation process that is going to allow me to extract the information at some certain points. And I'm going to have to spend a bunch of time studying and thinking about like what is the best places to extract. But I think one of the best places is probably going to be, I think the order of precedence doesn't matter that much because it's not that relevant to understanding, but maybe I'm wrong actually. Because one of the issues is that I should derive the meaning of how the keyword changes over time. I need to have the thing. So it's like I said, it's going to be both. So I think I need to figure out a way to extract information during the compiler and then choose that information. So like create a funnel where like I use the same information later on to see what happens. But I need to clarify how the problem is that in the course it doesn't speak about that, so I'm gonna have to study more, I think, on my own. The main concern that I have is with the time that I have to build this, because it's very complex, but I'm probably gonna have to spend a bunch of more time studying. Like, I'm gonna review the course again, and then I'm gonna have to study more on the later parts, because I wanna understand. As far as I understand now, the way that it works is it separates everything into lexers, which are tokens, and then uses those tokens to create higher level meaning by creating an abstract syntax tree that is going to contain nodes. And the nodes are the collection of some tokens that create some meaning. So for example, if you have an equation, 50 plus 40, 50 is a token, plus is a token, 40 is another token, and then each one has their type, and that's how it makes it easier to build meaning. And the way that you build meaning is by putting all these things together into a node of the parser, which would be an expression. So you construct meaning based on the tree, based on whatever specifications each node has. And then from that's the part that I'm not 100% sure, but I believe that on the parser, once you have the expressions, you create other meaning, like you create the assembly instructions based on the meaning you get from the things. Or maybe, I think probably what you do is you first create the expressions and like the abstract syntax tree, then you go over the abstract syntax tree because I think that the main reason for the abstract syntax tree is just organizing the information in a way that makes sense. So the order of precedence, for example, I think is the perfect example of this, where like separating everything into tokens first and then creating the abstract syntax tree makes it easier to see which operator should come first, because that allows you to restructure the tree in a way that is going to allow you to put the expression in the way that it is correct. So you just replace the order of the tree. So I think that's the main reason for the abstract syntax tree. So probably after that, you just go over the tree, the abstract syntax tree, and then you do the calculation based on the path of the tree. I think that's probably the way that it works. So the actual meaning of each thing at the resulting end of the command of the code is going to happen after you parse after you go over the abstract syntax tree, after you constructed it. So I have to think about a way to extract information as I'm building, and then at some point later on to apply the meaning to the information that I got. But it's kind of hard to clarify. I need to clarify more what exactly do I want to extract. The main thing that I'm thinking about, I think for the first use case, probably maybe the first one that I should focus on is just the names. So get the names of the variables and functions and put them on the graph. So the question would be, like, what is the best way to connect them? That's one question. Maybe I should just, in the very beginning, I should just put on the graph the abstract syntax tree and the tokens or something like that. But I have to think about this stuff as well. I think it's because of this that is not showing though. But it's so let me think. I guess the question is the connection. It's like how to create the edges. Because it's one thing to think about the flow of execution of the program when you have the higher level code, where you're just following the instructions. And it's another thing to think about it after it's converted into the abstract syntax tree. I think that's the thing that I'm struggling. Because I'm gonna have to put the information in a way that is gonna make sense for someone that doesn't understand abstract syntax trees. So like use the abstract syntax tree to reconstruct the other stuff, but it's kind of hard to think about. Yeah, the main thing is to figure out how to follow a variable along everything. So maybe one question that I should go back to the course and I should. The thing is that there's some parts that he doesn't go over in depth, but obviously it's because like the way that he's doing things is not related to what I'm trying to like. It's not fully related, so. And maybe he talks about this stuff on the other modules as well that I don't have access to. But one thing I should, like, what happens when a keyword variable? Now, variables are more keywords is on the token when you get the actual like the declaration of the variable. But to create the variable itself is more complicated, and this part is also confusing because I'm thinking about the other languages as well. But in C, you're gonna have the other stuff, and obviously the other languages as well, but it's gonna be different in the way that you compile. But each keyword is gonna have like the properties, different properties associated with it. Depending on the type is the main one that I think about now, but there's other stuff as well. So yeah, what happens when a keyword or variable becomes so it's both the variable and function, because the only place there is going to change. So this is related to scope as well. The scope is kind of confusing to understand in the course as well, but it's pretty much a linked list the way that I'm thinking about now. So like the problem that I'm having is deeper than that though. The question is, how does keywords, what happens when a keyword variable is passed through function, effectively changing its name? So from the compiler point of view, it doesn't change the name, I think. But if you're just looking at the high level code, like the name of the function is going to become something else. So like that's the thing. So let's say, for example, we have a global variable. Maybe global variables are different though. I'm not really sure. I think it's mainly global variables. Not so much. Because the hard part is to understand like how does the thing change depending on what part of the program you're at, I think. So it's probably mainly global variables. So for example, if you initialize a global variable with value 0, then if you're trying to understand manually what happens, you have to follow the execution of the code, and then the global variable is going to change all the time, and other stuff is going to change. So the question is like, how do you know at what would be the value of that thing at some point in the program without remembering everything that happens during that until the variable got there. So I think it does change because it starts off as the name. So for example, local variable, it's going to start with one name that if you pass that into a function, it becomes something else. But I guess the main fundamental thing is more like it's more fundamental than that. It's just the like understanding how the data is going to be shaped as the symbols change. So maybe it's related to the symbols. Yeah, because I'm trying to ask myself, like, how do I capture this stuff that remains the same, which is the core? Because the name, so for example, if you have a function, like this function here. So here is lax process. So I'm getting this thing here, and then I'm passing here. But then here, because of the argument, is going to be a different name. So here's compiler, but here's lax process. So there is a fundamental thing, which I think is the data. So the data structure is the thing that remains across the program. But then this name here, which was lax process, is going to become this thing here. So the question is, how do you highlight the thing that remains constant? The link of the data change between the names. I think that's the thing. But the challenge with that is that obviously, as it's parsing everything, it's going to separate everything into tokens and nodes in the tree. So the question is like, how do you know? I think it has to do with the keywords and variable, because that's the main thing. So I should figure out based on the name in the beginning, how do I keep track of the thing during the compilation process? So I can create the edges. Or maybe just create the edges, like I create a node, each node based on the thing. Maybe the Lexer is already this. Yeah, let me build this stuff first, then I think about this later. I don't know why it's not showing here, like it's highlighting the thing. Maybe I have to do like this. It's on the other one. And this one is not a pointer as well. It seems like only when it's a struct, it has a pointer. The other ones don't. Right here has a pointer as well. So let me think. So here the only thing I have to change is just obviously there is gonna be graph, and then here I point. The other stuff is this arrow here. So this is another thing that I have to see. I have to understand more when is the right time to use each one. Use either the arrow or the dot, because essentially they do the same thing, but the arrow, I think the arrow dereferences the thing, or the other way around. Maybe I should ask. I'm gonna ask ChatGPT. And the dot only accesses the thing, and the arrow dereferences or whatever. I know that both of them are for accessing stuff inside of a usually a struct, I think, but maybe there's other data structures you can do. Then here would be here would be nodes, and I think I don't need since I'm including this, probably resolves this. Actually, it doesn't need because it's from the graph. So yeah, but yeah, this hopefully resolves this thing here. Oh, it's just nodes and edges. And it should probably return this. No, that should be nodes and edges. Hmm. That's probably nodes and edges there. They're just creating the memory, creating the vector based on the size of the destruct. But yeah, I'm not really sure. I guess this is another question. It's confusing because obviously it's not going to be only one, but here isn't. I think here on the other one is not only one as well. There's not only one token that is going to be inside of this vector. So I think initially it just creates based on the size. Maybe it's just creating the space that it's going to allocate for each index of the thing. Yeah, I think that's how it works. So in the beginning, it initializes this space as like it initializes a block as with the memory that is going to require for each one, and then each element that you put is going to put another block of the same thing. So it's just getting the memory of the struct itself that you specify there, and then for each new thing that you add, it's gonna allocate another block of memory because you have to think about the memory, which is different than the other languages. So I have to think about the actual size of memory you're gonna use. So I think that's how it works. So I don't know, what should I do? That's probably pretty much. The only thing that is annoying me is that it's not highlighting there, so it makes me think that there's something wrong, but I'm also not getting any warnings. So here, I should close out these other files. It's pretty much the same. So, just gonna try to run make and see what happens. Also, I don't need these files here. Or maybe, yeah, I think I don't need these files. Because I was thinking about declaring the nodes and edges on the files themselves. But it makes more sense to just declare because it's not that much stuff. It just makes more sense to declare everything on the graph, and then, which is another difference from the other languages. Because here it seems like it is the best way to do it. You declare on the H files the stuff that you're gonna use, and then you initialize on the other files. So I probably, yeah, this way is probably fine. So, and then returns the process. Yeah, so let's see. No rule to make targets graph. No? Oh, it's because I deleted. So should I delete everything? I think I should delete this, and then I just delete from here as well. So it has to be before the thing, maybe? Maybe that's why it's not highlighting there. Oh, but... Yeah, I don't understand why here... Oh, maybe it's the other way around. Like this. Or it's on the function itself. Yeah, that's probably what I'm doing wrong. Yeah, it's on the function itself. That's the thing. So this one is correct, I think. Oh, but I should probably... I have to put a different name, I think. Because it can't be the same name. So... That's probably better to... Oh, let's... Oh, here's just process. So let me think about it. I think it's probably better to leave this struct as graph and then change this name here. So I have to think about a different name. I'm just gonna put anything here, then I'll think about this later. But it's not highlighting here, so I'm probably doing something wrong. I don't understand what though. Okay. Oh, it's because it's not a struct. No, it is a struct, I think. Or maybe because I didn't. No, it has to be the other ones. But let me think about this. No, I think it makes sense to be the other ones because it's gonna be, each one is gonna be one. So, like, because these ones are vectors instead of the other one, so it's not gonna be the size of the thing. But why did I? Oh, it's kind of confusing me. Oh, it's because I'm initializing them here. That makes sense. So I passed the size of the thing, so I think this makes sense. And now he's complaining about the vector. So... Oh, how do I do this here? Can I do this? Just struct vector. And define reference probably because... No, but you shouldn't have to declare because... Yeah. Oh, I have to define on the other one. So I have to define on the H file, I think. Here as well. Hmm. Here I should probably have the thing again. Oh no, yeah, it's here. So let me think. What is going on? Was because of these ones, maybe? So I know, like, there's a problem here with this, I think, and a problem with the definition here. And I don't understand. Maybe it's because of the flag. I wonder if I use this star is gonna... So first I'm gonna run like this, I don't know, think about it. But I know that maybe it's because of the way that I'm using the include that is not finding the vector create. So I'm pretty sure that, yeah, I just copy the other one, so it should be this name. And the rest should be fine now. So I have this name and I have the struct graph, which comes from this one. Graph. Graph. Then the size here. I think this is fine. Fine. So it should be the problem should be on the make file, I think. It's probably because of the input here. So I guess I should try some stuff and see if it works. And define reference. So I'm pretty sure that is not finding the helper's vector. And let me see on this one how is defined. Maybe I should do it with this, since I'm including from the parent. Maybe that's the problem. Yeah. There's also this thing here that I don't understand. Maybe it's because this is something I was thinking about as well. Like on the other one, it has objects here, so this might be the reason why it runs this stuff first instead of running this command. So it builds everything first instead of running this first. But not sure if not having this breaks the thing. I think it shouldn't, because okay, it doesn't matter. So let me do like this as well and see what happens. The other thing I can do is just try to compile, like try to move this make file, like temporarily remove the other one and move this one to the other directory and see if it compiles. But yeah, also this works. But now, so maybe if I put the directory like this, is it gonna find? Yeah, but it's still, even if it works, I'm gonna search, so it doesn't find. Because it's obviously better if I just include from the other directory, I think. But maybe it's not working because it is assuming I'm specifying that it's gonna be to include all the files that are from this directory, but then the other one's like one above, so it doesn't make sense. Yeah, maybe if I put graph here, or maybe graph O. And if I do it like this as well. So this might be the reason why it builds everything first. So maybe I should build first and then... Yeah, but if I'm not gonna use... Yeah, I guess like, this is the question. Because I'm just trying to do the thing. I'm just getting the executable directly. I don't need to build the other objects files because I don't have any other file, I think. So... these objects here doesn't make sense because I'm not building anything else, I think. So it's probably not the problem here. Also here it does put this. So I guess this is just a label. So it goes to the label. That's how it works. But if I don't have anything there, you should run the commands. It's just easier to put the whole thing there and see if it says anything useful. I think the problem is that it's not finding the definition here. Maybe if I do like this. If this is the case, then I have to graph here as well. And the thing is, like this other thing here, it might be something different because of this. But it's giving both, so it should be because of the include here. What if I run from here? Or maybe it's because of the... No, but the slash O shouldn't be anything. Yeah, it's just these three places. It can also be because this one, like it has the other object file, so this one doesn't need to create an object file for the main because the other ones have. So I guess what I can try as well is just put the graph in the same way that this one are. This one is. But I think now I understand what is happening. Like here are labels, so when you encounter this, it goes through whatever the label is. And then once it goes to the label, it calls the file. So maybe it is, maybe I do have to put here graph C. Maybe that's the, I think the problem is this, like this is this problem here. And the other one is probably because of the include. Let's see. No, it still has the same thing. Yeah, but I'm pretty sure now that's how it works. Because I just realized that it makes sense because this one has the two dots here. So here it defines all these labels, and then as it encounters the labels here, it goes to the part of the file that has the label, and then it runs the file for the label, and then it runs the command to build the, or specifies the file, and then it runs the command to create the object from the file. But I don't, yeah, like I don't understand why it's not working there. But it shouldn't be graph.exit the problem. And it's not like this because this one is working, so, and this one creates the executable. So I'm not really sure what's going on. Oh, maybe I can look at in the other project. I think there is a make file on another project that I'm gonna do that. I'm gonna search for the other ones because I can find another one. It's obviously gonna be easier to figure out. I think it's on the tests that there is another make file. Yeah, here. Yeah, but this one is different. Oh, maybe it's because I'm putting as C there, so. this now. Huh. It's giving me another error now. Yeah, but it's because you can't find the thing. Oh no, here is objects and the other one. So I think that's, yeah, here is just a label, so. But maybe I should just create a label here. A graph. Or views. Views, graph. Let's see. The thing is that I don't want to create object, but maybe that's fine. I'm thinking about creating the label and then just putting the label here and calling the file then. But it should work if I just put... It's probably something else, the issue. Because if I put graph C here, it should work. Because if I put another label here, it's just gonna do the same thing, but in another time, I think. Oh, it's probably because I don't have a main function. I think that's the reason that I'm getting this one here. So it's probably how it works on the other one. Is the thing that I was thinking about in the beginning. Because the other one, it creates the executable, but it doesn't call the function. And it still runs the executable. So I think there's something in C that requires you to have the main function, and then it just runs the function automatically. So let me see if I put here this, if it's gonna, one of the warnings is gonna go away. Yeah, that was the problem. So, but this is like the thing that I was talking about in the beginning that is kind of hard. One approach is to change the other makefile so that I figure out a way to only run the stuff that I wanted to run at each time. Like if I specify some argument on the command line, there might be a way to do that. So, but I need to research what is the best way. Like, but the thing is that this is, for the reasons I explained before, this is going to be kind of hard to search, I think. Like I want to understand what is the best practice to test stuff as you build. It's probably using GDB, I think. But even if with GDB, the thing is that I'm gonna have to compile everything. So I want to figure out like what is a way that I can do it so that I only compile the files that matter for the thing that I'm trying to test. So I don't have to recompile everything each time. And I can just execute that. And this is obviously related with linking, I think, because it's the reason why linking exists is to optimize this process. So it has to do probably with something with the way that you declare the include, with the way that you create the header files. But yeah. So the thing now is the other statement there, which I don't know how to do it. So I should search for. So one thing that I'm thinking about searching is how to find how to know if the compiler or the linker is finding the correct path. Because there can be two problems. One is this one, the path here. The other one is the path here. So it could be the case that this one is correct, but then because this one is searching for the directory that I'm currently at, it should be one level above. So it should be like this. Yeah. Oh, let me see on the other one if he includes stuff. No, doesn't include anything. Hmm. Or maybe just putting the name of the... But that feels kind of weird because... So... It doesn't make a lot of sense, but maybe... Just gonna try because don't lose anything by trying. I guess I can... Yeah. Like... The star also doesn't make a lot of sense. I think. No, it doesn't change anything. Interesting. So now it shows a difference. So it should be working correctly. No? So why am I still getting this thing here? And there's the... maybe it comes from another library, but yeah, pretty sure it comes from this. So why is it not finding there? Well, maybe it's no, but it doesn't make sense. Like, I shouldn't have to declare again on the other. That doesn't make a lot of sense. Vector creates. Yeah, it doesn't have anything. So the only explanation is this thing here, as I can try with this. It's interesting that it gave me the wrong directory there when I had, so like it makes me think that this should be correct. Yeah, so this is probably not gonna, it's not the best. So I think that this is probably the correct way. What if I put helpers here? But obviously is not the best. It still doesn't work. Maybe it's because of this. Yeah. So that's the weird thing, is like it is getting there, but for some reason, like it is finding the file, but for some reason it's not finding the function. Oh, did I type it wrong? No, it's just the path. Hmm. Oh, maybe it's because but if I just put... I guess I'm gonna try, but it doesn't make a lot of sense, sure. If I put it like this. Maybe it has to be connected here. Maybe that's the issue. So maybe the I goes to the directory that you're currently at. Maybe that's what's happening. Yeah, but... Because the thing is that when you put it like it was before, it was fine in the file, I think. Otherwise, you wouldn't complain that the path is wrong when I change. But if it's fine in the file, then how is it possible that it's not finding the reference? Maybe it's finding the wrong one, but that's also... Or maybe it's because... No, it's not on the build. Oh, it's because I'm... No, let me think. Yeah, if the I is the directory that I'm currently at, it should be one above, which would be this one, but... I do think it's finding the thing, otherwise it wouldn't be warning like this. No, but now it doesn't. So maybe the other name is probably the correct one, but then why isn't it finding the reference? I guess I can, yeah, but here is not gonna change anything. I think I'm gonna solve this off stream. This might take a lot of time for me to figure this out. I think I'm on the right track, but the thing is, there might be multiple different ways of going about it, and I have to think about like what things I can try that makes sense. The first thing that is coming to my mind is trying to search for how can I see if it is like what is the path that is trying to link the file from. I have to clarify this stuff about linker as well, and module systems. I watched some videos I think yesterday or 2 days ago, but Like, because there's so much other stuff to study, I didn't like go too much into that. But I think now I'm probably gonna do that. The thing is, I have to go over the course again and like, study other stuff. So, but I think it's probably very important. Um, I'm probably gonna do the C course that I found. I'm gonna do the C course that I found. The problem is that it's like 20 hours. But I think I'm gonna do that first. Then after I finish that, then I go more into that. Because in the course, hopefully he's gonna talk about this. And there's also another course just about make files. Maybe I should do that as well. Because the main thing is like understanding better how the linkers work. Yeah, that's what I have to figure out. The other thing that it could be is the dissolve file. But for me, that doesn't make a lot of sense. Because I just want to create the executable and not the object file. But maybe that's the problem. So maybe I should ask, how can I see? And see if I can get anything useful. And this is the problem, is I'm using chocolatey, however you say that. And it's probably doing some stuff that I don't understand, because the files that he's using to compile is on another project, and those files are gonna decide how everything is linked. So maybe the path is different or whatever. But it should be the relative path, because on the other one works. So the I should be up until the path that I'm currently running the command from, I think. The other thing, it could be this thing here. I have to study the flags as well. So it probably is going to the correct one. It's one up, and then helpers vector. I wonder if it is because... Shouldn't be because of this, because the vector C file is on the also on the other one. I think that doesn't make sense. I think I'm gonna solve this off stream. Already past the time, and I don't want to stay here for a long time. So what I'm probably gonna do is just use ChatGPT and then just use search engines to find information. It's probably not gonna, hopefully it's not gonna be that hard. But the main thing that I wanna understand more and I'm gonna spend a bunch of time is understanding the linker. So I'm gonna spend time studying the linker and the module system, and also this flag variables here. These flags for the commands, like what do they do? The only one that I know is the O, which is the output. The other ones I don't know very well. So it's probably, I should probably spend time studying this before I do. Because the main thing that I have to do first is to see if this runs, or if it compiles. If it compiles, then it's probably because everything... But this is the thing that I have to clarify as well, because I have to see what is going to be the best way to test, because I don't want to run here, because I guess I can just call the function here and see. Maybe I do that. So like I assign a variable to the create graph here, and then I print the variable, or print the values of the graph that I get to see if they work. But I think I'm not gonna do that. If it compiles, I'm gonna just trust that it works, and then I'm gonna move to trying to implement the other... I'm gonna implement other functions here that get the information, whatever information I want from the compiler, and translate that into the node struct or the edge. And I have to think about, spend a lot more time thinking about how I'm gonna construct the edge. But initially, I'm just gonna do the simplest thing possible, so I don't get in paralysis by analysis. So I'm just gonna find a way, probably to connect sequentially the lexer and the nodes in the parser. And then, yeah, I'm gonna add those functions inside of the compiler and then translate the information into the graph node and graph edges, sequentially connecting them, and then create the graph that way. And then after I figure that out, I'm gonna try to compile and then run, obviously, to see if it runs. If it runs, I guess that's the problem, because I'm not gonna be able to know. But I don't think I'm gonna spend time testing, at least for now. Like, I'm gonna study the other part as I do this stuff. So when I do this stuff, I'm just gonna compile and run. And if it runs, I'm just gonna look for how to save the information, save the graph on the JSON file. And I'm probably gonna have to create other algorithms that go over the vectors in the graph to save. Or yeah, I'm gonna see with ChatGPT probably, or just searching online, and then like save the information of the graph into a JSON file, and then from the JSON file I pass the file to the front end, and then I see how the graph looks like. And then once I have that, then I'm just gonna iterate over that a bunch of times until I get just something that I think is good, like, or like it seems useful. And then I'm gonna try to do I'm gonna try to parse I think I'm gonna start with Python interpreter first, because for Python there's less stuff like that. In JavaScript there's more stuff that helps you debug stuff, but for Python I haven't seen like anything that helps you with this kind of stuff. So I think it's better probably just start with Python and then go over to JavaScript. But what I'm gonna try to do is just use the stuff that I built to understand the Python interpreter. And then once I understand the Python interpreter, then I can use the interpreter or modify the interpreter to also create the graphs. And then the main thing that I'm trying to understand or clarify is this fundamental thing that I talked about today, which is the essence of the thing that I'm gonna do, which like hopefully I can get to a place like I have the design of everything of how it's gonna work, and then from that place is gonna be the same in any language because the main structure is always gonna be the same. It's just converting the information of the code into visualization. Then after that point, I can just like I want to do things in a way that allows me to just apply the same thing for any function and just change the compiler or interpreter of the function. Uh, like don't have to change that much so it works. So yeah, but it's gonna take a long time. I'm not really sure when I'm gonna come back, but it's probably gonna take like 2 days or more until I come back again because I'm gonna do the courses now, the C courses, and then I'm gonna think about all this other stuff. So, but when I come back, I'm gonna continue to do this stuff definitely. So.